In this video, I will show you how to add or subtract mixed numbers, so let's get cracking. Here we have the addition of two mixed numbers, 7 and 1/5 plus 2 and 3/4. How do I add these two mixed numbers? Well, the easiest way, step 1, is to add the integer parts, the whole number parts, 7 and 2. So 7 plus 2 is equal to 9. And then what we do, we add the fractional parts, 1/5 and 3/4. So 1/5 plus 3/4, what is that equal to? Well, the denominators are not the same, so I need to make the denominators the same by finding the lowest common multiple. The lowest common multiple of 5 and 4 is 20. How can I make this into a 20? I need to multiply it by 4. If I multiply the denominator by 4, I must multiply the numerator by 4 to keep the fraction consistent. And then this one, to make that into 20, I need to multiply that by 5. And I must do the same to the numerator. Now this simplifies to 4 over 20 plus 15 over 20, which equals 4 plus 15 is just 19, so that's 19 over 20. And you must always check that, is this in the simplest form? This is in the simplest form. This cannot be simplified any further. Now what we do, we just add the part that we worked out in step 1 to this fraction here. So in the final step, we add 9 plus 19/20, 9 over 20, which equals 9 and 19/20. And this is my answer. So the answer to this addition is 9 and 19/20. An alternative method you could use to add mixed numbers is to convert each of the mixed number into an improper fraction. So convert each of these into improper fractions. Now, what is 7 and 1/5 as an improper fraction? Well, all I need to do, I need to multiply the 7 by the denominator here and then add the numerator. 7 times 5 is 35, plus 1 is 36. So this will be 36 over 5. And then the other mixed number, I do 2 times 4 is 8, plus 3 is 11. So this will be 11 over 4. Now, clearly the denominators are not the same here, so I need to make the denominators, the bases, the same before we can add these fractions. Now, how do I make the denominators the same? Well, what is the lowest common multiple of 5 and 4? The lowest common multiple of 5 and 4 is 20, so I need to make each of the denominators into 20. Now, clearly to make this denominator 5 into 20, I need to multiply it by 4. And if I multiply the denominator by 4, I must multiply the numerator to keep the fraction consistent. And to make this denominator into 20, I need to multiply that by 5. And then I need to multiply the numerator as well by 5 to keep the fraction consistent. Now, 4 times 36, well, 4 times 30 is 120, 4 times 6 is 24, 120 plus 24 is 144. So that's 144 over 4 times 5 is 20, so that's over 20, plus 11 times 5 is 55, so that's 55 over 4 times 5 is 20, so that's 55 over 20. Now that the denominators are the same, I can just add the fractions. 144 plus 55 is just 40 add 50 is 90, 4 add 5 is 9, so that's 199 over 20. Now, is this fraction in its simplest form? Well, we check this by seeing, is there a common factor? Is there a number that divides both of these numbers? And the clear answer is no. There is no number that goes into 199 and 20. So this fraction is in its simplest form. Now, we can write our answer as a fraction, and clearly this is an improper fraction, so I can write my answer as an improper fraction, or I can convert this improper fraction into a mixed number. How do I convert this into a mixed number? Well, all you need to do is see how many 20s go into 199. Well, clearly 20 times 9 is 180, and the remainder will be 19. So there are 8 lots of 20s that go into 199. So the answer to this is just 9, and the remainder is 19 over 20. So the answer here is 9 and 19/20. Now, do you see that I get exactly the same answer as the first method that we employed? Whichever method you use, you'll get the same answer. Use whichever method you find comfortable. Now, I find it easier to use this method. Here we have another question, 3.5 plus 4 2/3. So once again, step 1, add the integer parts, the whole parts. 3 plus 4 is 7. And then what we do, we add the fractional parts, half plus 2/3. So a half plus 2/3. Now, clearly you can see the denominators are not the same. We need to make the denominators the same. What is the lowest common multiple of 2 and 3? It's 6. So I need to multiply this one by 3 to make that into 6, and I must do the same to the top to keep the fraction consistent. And to make this denominator into 6, I need to multiply this by 2. And I need to do the same thing to the numerator to keep the fraction consistent. Now, this just simplifies to 3 times 1 is 3, 3 times 2 is 6, so this simplifies to 3 over 6, and the other fraction becomes 4 over 6. Now that the denominators, the bases are the same, I can just add these fractions now, and when I add fractions, I just need to add the numerators. 3 plus 4 is 7, so the answer here is 7 over 6. Now, what do I do here now? Normally I would just add this fraction to the integer, combine the fractional answer to the integer, and that would be my final answer. But you should immediately notice here that 7 over 6, 7/6, is not a proper fraction. It is an improper fraction. And so we cannot just combine this fractional part to the integer. What we need to do is convert this improper fraction into a mixed number. So if we convert this into a mixed number, how many 6's go into 7? Well, clearly into 7, only 1 6 goes into 7, and the remainder is 1. So the answer to this one is 1. Remainder is 1, so we write the remainder 1 over the divisor 6, so that's 1 and 1/6. Now what we can do for the final step is we add the integer part that we worked out, the integer value that we worked out, to this part here. So 7 plus 1 and 1/6, which just equals to 7 plus 1 is 8, so that's 8 and 6. So the answer to this addition is 8 and 1/6. The reason why I'm showing you this question here is to emphasize a point where students make a mistake. Students come to this part here, they get this answer here, and then they just combine this with the 7 here. So they write their answer, they just combine these two and just write their answer as 7 and 7/6. This is wrong. What is wrong with this? Well, in a mixed number, the fractional part cannot be an improper fraction. The fractional part has to be a proper fraction. So this is wrong. The improper fraction must be converted to a mixed number and then you add it to the integer part. The easiest way to subtract mixed numbers is to convert each of the mixed numbers into improper fractions. Now if I convert 7 and 2/5 into an improper fraction, then how do I do this? Well, I do 7 times 5 is 35, plus 2 is 37, so that is the numerator. So that's 37, and the denominator will be 5. And then I do the next one. 4 and 3/7 will become 4 times 7 is 28, plus 3 is 31. So that will be the numerator, 31, and that will be over 7. Now, clearly, the denominators are not the same here, so we need to make the denominators the same. How do I do this? Well, the lowest common multiple of 5 and 7 is 35. So I make each of the denominators 35. So for this fraction, to make the base into 35, I need to multiply this by 7, top and bottom by 7, to keep it consistent. And for this one, I need to multiply the denominator by 5. So if I multiply the denominator, I must do the same thing to the numerator so that the fraction does not change. So 7 times 37, well, let's quickly do a column method of that. 7 times 37 is just 7 times 7 is 49. Carry the 4 there. 7 times 3 is 21, plus 4 is 25. So that's 259 over 35. And 31 times 5, well, 30 times 5 is just 150. 1 times 5 is 5, so that's 155. So that's 155 over 35. Now that the denominators are the same, I can subtract the numerators. So 259 minus 155. We quickly can just do a column method subtraction of this. 259 minus 155. 9 take away 5 is 4. 5 take away 5 is 0. 2 take away 1 is 1. So that's 104 over 35. Now, can I simplify this? Well, is there a common factor? Is there a number that divides 104 and divides 35? No, there isn't. This is already simplified. You cannot simplify this any further. So my answer to this subtraction here is 104 over 35 as an improper fraction. Now, if I write this as a mixed number, then how many 35s go into 104? Well, clearly 2 times 35 is 70, 3 times 35 is 105, which exceeds 104, so only 2 lots of 35 go in there. And the remainder, well, what's 104? 2 times 35 is 70. 104 minus 70 is just 34. So the remainder is just 34 over 35. That's the fractional part. An alternative way of subtracting mixed numbers is similar to that of adding mixed numbers. What we can do when subtracting mixed numbers is to subtract the integer parts first, and then subtract the fractional parts, and then combine the answers. So let's do this. So step 1, we subtract the integer parts first. So 7 minus 4 is just 3. And then step 2, we subtract the fractional parts, well, 2/5 minus 3/7. Now here you have to be careful. 2/5 minus 3/7. Now, are the bases the same? No, the bases are not the same. We need to make the bases the same. The lowest common multiple of 5 and 7 is just 35. So in order to make 5 into 35, I need to multiply this by 7. So I need to multiply the top as well by 7. And here to make the base 35, I need to multiply this by 5. And this simplifies to 14 over 35. And minus 15 over 35. Now 14 minus 15, here you can see my answer will be a negative. My answer will be minus 1 over 35, because 14 take away 15 is minus 1. Now what I need to do in step 3, I need to add the integer value there with this value here. Now how do I do this? Well, 3 plus the minus 1 over 35 is exactly the same as plus minus makes minus. So this is exactly the same as 3 minus 1 over 35, which just equals to 3 take away 1 over 35 is equal to 2 and 34 over 35. Now, you're probably wondering, how did I do this in my head? Well, with a bit of manipulation. Now, I know that 3 is the same as 2 plus 1, and then I'm taking away the 1 over 35. Now, 1 take away 1 over 35, 1 can be manipulated and written as 35 over 35. So that's 2 plus 35 over 35 minus 1 over 35. Now that the denominators are the same, I can easily do this subtraction. 35 minus 1 is 34, so that becomes 2 plus 34 over 35, which simplifies to 2 and 34 over 35. So the answer to this question is just 2 and 34 over 35, which is exactly the same answer as the previous method I showed you, where we converted each of the mixed numbers into an improper fraction. Now, I think it's easier when it comes to the subtraction of mixed numbers to stick to the first method I showed you, where you just convert the mixed numbers into improper fractions and then just subtract them by making the bases the same and so forth. This method was slightly tricky because when we subtracted the fractional parts, I ended up with a negative answer. And then when I had to add these answers, some people find it difficult to add a negative value to a positive value. Now, if you are not comfortable with this, if you are not confident in adding and subtracting negative values, I would say stick to the first method I showed you, where you convert each of the mixed numbers into improper fractions and then just work out the answer